Okay, today we're talking about a new format called point-slope form. It's called point-slope form. Previously we've learned really just one other form, but there's three major forms that you're going to see equations written in. Here's the one that we have learned already, slope-intercept form, right here. Y equals mx plus b. I gave you an equation here just as an example. Y equals negative 2x plus 5. And we learned that this number here is the m, or the slope. So the slope in this equation is negative 2. And we learned that this number is always the b, which is the y-intercept. So the y-intercept here is 5. Another way of writing equations is called standard form, right here at the top. Now this is actually the same equation. One is written in standard form, and one is written in slope-intercept form. Okay, so the numbers look totally different here. This is actually the same equation, and I'll show you right now how we go from one to the other. Now today's lesson is on point-slope form, but we're going to get to that in a second. First I want to talk about going from standard form to slope-intercept form. Okay, so here's that equation that I just had up here, and this one again is in standard form. Here's how you recognize standard form. It has the x variable and then the y variable on this side of the equal sign. And then it has a constant, just a regular number, on this side of the equal sign. So that's standard form. You have the x, the y, and then just the regular number, the constant, on the right side of the equal sign. Okay, so we've already done this before, but just as a review, how do we turn this into slope-intercept form? Y equals mx plus b. Okay, well first we would subtract 4x from both sides. That would give us 2y equals negative 4x plus 10. And then we would divide by 2 on both sides. That would give us y equals negative 2x plus 5. Y equals negative 2x plus 5. See, that's exactly what I had. Y equals negative 2x plus 5. So you can see that these are actually the same line, even though they look like very different equations. This one looked like this to start off with. This one looks like this. They're the same line. Okay, so standard form, slope-intercept, or y equals mx plus b form. And then today, we're focused on the third and final form that we're going to be talking about, which is point-slope form. Point-slope. And the way it looks is this. Y minus y1 equals m times x minus x1. Okay, again, all seems very confusing at first when you don't know what's going on, but I promise you, it's no harder than y equals mx plus b. It's actually very similar. Okay, so as the name suggests, in point-slope form, all we need in order to make this equation is we need any point and the slope. That's why it's called point-slope form. Okay, we need the point and a point and the slope. So as an example, I said, what about this? What if the slope, the m, is 4, and what if the point that we're going to use is 3, 2? Okay? Well, here's all you do. It's as simple as this. You're putting these numbers into the correct place in that formula. Okay? So, you have y minus, what's y1? Well, here we have our point. Remember, the first one's always x, and the second one's always y. Okay? In this case, we don't even have 2 points. You know, in the slope formula, we had x1 and y1 and x2 and y2. Here we just have 1 point. So this is x1, this is y1, and that's all there is to it. All right, so y minus, what's y1? It's the number 2 in this case. Okay, so y minus 2 equals, in place of m, well, we put 4. Parentheses. And then we have x, that just stays as x. This y stays as y, this x just stays as x. Okay, but it's x minus, what's x1? It's 3. And there you go. That is point-slope form. We have correctly put that equation into point-slope form. If it has a slope of 4, and we know a point on that line is 3, 2, then this would be how you create it. You could use any point on the line to make this equation. For example, if we found out that another point on this line was 7, 3, then another way we could have created this equation was to say Our slope is still the same, slope is 4, but this time we're going to use this point. Okay, so now here's the x1. We'll forget about this. And here's y1. So we could have said y minus 3 equals 4x minus 7. That's fine. You can use any point as long as that point is on the line. Okay, as long as it's on the line. And that is point slope form. Okay? So, now that we know that, let's go back to our original question. We had these three forms. And we already talked about how we could turn standard form into slope-intercept form. Well, how do we turn slope-intercept form into point-slope form? Okay? Well, what did we just talk about? What do we need? We need any point, and we need the slope. And what's our formula? It's y minus y1 equals m times x minus x1. All we've got to do is figure out what m, y1, and x1 are. Okay. Well, here's slope-intercept form. What's the m? That's the easiest thing to figure out. Remember, m is always this number right here. So the m is negative 2. There we go. We've already figured that out. If m is negative 2, then this m is also negative 2. That just stands for the slope. Okay? Now we need a point. We need some point that's on the line. Well, what point do we know is on the line? How about the y-intercept right here? The y-intercept is 5. That means there's a point at 0, 5. There's our point, 0, 5. Okay, very easy to figure that out. So now let's enter those numbers as our point that's on this line. The x1 is 0. The y1 is 5. And there we go. Now we have the same line written in three different forms. Standard form, slope-intercept form, which is y equals mx plus b, and our new one, point-slope form. These all mean the exact same thing. If you graph these out, you'll get the same line 3 times in a row. Okay, now what would it mean if we had an equation in point-slope form and we were asked to graph it? Okay, well again, not too hard as long as we remember what each number means. Okay, remember, this is y1 and this is x1. So what that means is we already know what one point on our line is going to be. Okay, if this is y1 and this is x1, then we rearrange it and we figure out that the point is, remember x always comes first, so the point is 5, 3. 5, 3. The tricky thing here is, remember these are minus signs, but it's supposed to be minus signs. If it says y minus 3, that means it's actually positive 3. Okay, so you got to remember that. That's the only tricky part. So we have a point at 5, 3. Let's find that. 1, 2, 3, 4, 5. 1, 2, 3. Okay, fine. There's one point. Now, we also have the slope, negative 2. Okay, so if our slope is negative 2, let's find one other point. 1, 1, 2. There's one other point. We're going to graph our line through it. Line looks like this. All right? All we needed was that one point, and then we used the slope to find one other point on the line. We drew the line. Okay, let's look at one more example. Let's say we had y plus 4. Okay, y plus 4 equals 1/2 x minus 1. Okay. Remember what the formula is. It's y minus y1 equals m times x minus x1. Okay. So again, we've got to start off by finding our first point. We need the x and the y for the first point. Well, the x is 1. That's really easy. Okay. The y. The y, see, here it says 4, but do you see how this got turned into positive 4? The equation says that's supposed to be a minus sign. How could it have been turned into a plus sign? The only way is if this 4 is actually negative 4. Because think about it, then we would have y minus negative 4. And minus a negative is the same as adding a positive. Okay? So that gives us a clue that this had to actually be negative 4. So our point is at 1 comma negative 4. Let's find that. 1, negative 4. And then following our slope, the slope is 1/2. So we're going to rise 1, run 2. We could do it again. Rise 1, run 2. There's our line. There we go. We just graphed another one. All right? So that's how we can graph equations that are in point-slope form. One final thing. How could we turn point-slope form into y equals mx plus b? Well, remember, our whole goal to get something into y equals mx plus b is to isolate the y, to get the y all by itself. So that's our goal here. We want to get the y all by itself. Our first step here is actually going to be to look at this side. We've got negative 2. We've got this. Those of you who remember our chapter on distributing can tell this is a dead giveaway for distributing. So that's going to be our first step. Y minus 3 equals negative 2x plus 10. And then to get the y all by itself, all we have to do is add 3 to this side. That gives us y equals negative 2x plus 13. And there we go. We've turned it into y equals mx plus b form. Okay, that was a lot of information, I know. I recommend you watch this video actually 2 different times. I think it'll take you watching it 2 different times before it starts to click a little bit. We'll work on it in class. Don't forget to answer the question, and don't forget to remind your friends to also watch the video. See you tomorrow.